Hello, welcome back to chapter 4, section 4.5, where we're going to talk about the graphs of sine and cosine functions. And I really, I really like studying the graphs of sine and cosine because it really helps tie in all the theory that we've been learning, and it really helps to illustrate how it's periodic and what the values are at a certain point, and it's just a really cool concept. So let's get into it. So our goal is to be able to sketch the graphs of sine and cosine and to be able to use amplitude and period to help sketch these graphs and then to sketch translations of the graph. Okay, so let's look at the basic sine and cosine curve. Okay, so first let's talk about the graph of the sine function. We call it a sine curve. It looks like this. Okay, if it's just plain old y equals sine of x. If you look at the black portion, it starts at the origin and it goes. The x-axis will be the input, so the measure of the angle in radians, and the y is just where it goes, right? What's the value of the function at each possible angle? Now, if you remember, the unit circle keeps repeating, but here you can see it as a wave. Okay, so it starts here at the origin, and as x increases, it goes up to 1. That's at pi over 2. And then it comes back down to 0 at the value x equals pi. Then it goes down to negative 1 at 3 pi over 2. And then all the way back to where it began at 0, y equals 0 at 2 pi, which makes sense, right? And this is considered one period or one cycle. And sine of x is known as periodic, meaning that it keeps repeating and repeating infinitely many times. So usually when we begin to study sine and cosine, we zero in on one of the periods, and we talk about all the parts of it. Now cosine is very similar to sine, except it doesn't begin at 0, 0. It begins here at 1, and it comes back down, and it approaches 0 at pi over 2. And it goes down to negative 1 at pi, so cosine of pi is negative 1, and cosine of 0 is 1. Then it comes back up, hits 0 again at 3 pi over 2, and then finally at 2 pi, it's equal to 1. So cosine of 2 pi is 1. So they're very close to each other. If you look at them, notice how sine is this, looks like, one period of sine looks like a mountain and then a hill, and cosine kind of just looks like a valley coming back up. Let's see, what else do we say? We know that the domain is all real numbers, and the range is negative 1 to 1. Sure, it's never going to get higher or lower for just sine of x and cosine of x, right? There are other things we can do to make it go higher, but right now we're just talking about the basic functions. So yeah, that's its range. And then what else? And then the period is 2 pi because it's going to keep repeating and repeating, right? So it starts at 0, ends at 0. Here starts at 1, y equal 1, ends at y equal 1. So also we have that the sine curve is symmetric with respect to the origin, and cosine is symmetric with respect to the y-axis, okay? This makes sense because sine is odd and the cosine function is even. All right, so how would we do this by hand? So let's notice there's 5 key parts or points in one period of the graph. And we're gonna go ahead and tear these little parts apart. So you have here the intercept, or the beginning, right, or the beginning of the period. So for sine, let's look at sine first. So 0, 0 is where it begins, and it ends at 2 pi, comma 0, okay? The middle point is at pi here. That's an intercept, so it has 3 intercepts. And then it has a maximum for one of the hills and then a minimum. So it has a maximum at pi over 2. In other words, it's the quarter period. And then at pi is half of the period. And the minimum at 3/4 period, or you can also think of it as 3 pi over 2 specifically for this sine of x. And then finally, when we come back to 2 pi, it's gone through one whole period. Okay, that's sine. So now cosine, similar, except that it has two maximums and 2 intercepts. So notice that while sine has 1, 2, 3 intercepts in one period, a maximum and a minimum, cosine begins at a maximum, right? It begins at y equal 1. It comes down to 0 at the first quarter period, which is pi over 2. Okay, it has an intercept there. And then down to pi to negative 1. So it has a minimum at pi, which is the half of the period. And then coming back up to 0 at 3 pi over 2, which is also known as the 3/4 period. That's an intercept here. And then finally going back up to a maximum at 2 pi, and that's the end of the full period where it's 2 pi, right? Okay, so let's use key points to sketch a sine curve. So let's sketch y is equal to 2 sine of x on this interval negative pi to 4 pi. So notice that y equals 2 sine of x is equal to 2 times the quantity sine of x. So what does that mean? That means that the y values for these key points will have twice the magnitude of those on the regular graph y equals sine of x. So basically so when you graph this at points of, key points at sine of x are going to be multiplied by 2. So it's going to be like kind of stretched vertically, right? It's going to have a vertical stretch. Remember that from transformations. It does apply. So let's say here let's say we want to talk about the key points. Let's divide the period into 4 equal parts. So basically, if I took 2 pi and I divided by 4, 1/4 of that is pi over 2, right? So it would go from 0, pi over 2, then add pi over 2 to pi, add pi over 2 to 3 pi over 2, and then add pi over 2 to 2 pi. So those are the points, right? So it begins at 0, 0. Okay, if I plug this in to pi over 2, it's going to be 2 times 1, which is 2. And then here, 0 is still 0. Sine of 3 pi over 2 is negative 1. But since I'm multiplying that by 2, it's negative 2. And then 2 times 0 is still 0. So the graph looks like this. Okay, so here I have 0, 0. Then it goes up. And it comes back down to 0. Then goes down to negative 1. And then comes back up to 0. And continues every pi over 2 until it reaches 8 pi over 2 or 4 pi. And just to come back, since this is the part right here, we know that it's periodic, so it's going to repeat. Okay, it's going to repeat the valley. Okay, so yeah, so it's very similar. Has the same intercepts, except that the maximum, instead of being 1, now it's 2, because this is 2 sine of x. Yes, and we have a name for that, and we're going to get into what that is. So here we have amplitude and period. Okay, so for the rest of this part, we're going to talk about the general form of the graph y is equal to d plus a sine of bx minus c, and y is equal to d plus a cosine of bx minus c. So these are the two forms that we can talk about different translations here. So a, this factor a is in front of sine and cosine. It's a scaling factor. It's a vertical stretch or shrink depending on what the value is. So when the absolute value of a is greater than 1, it's a stretch, right? And when it's less than 1, it's shrunk, or it's, you think of it, it's a vertical shrink. Okay, so what's the result? So the result that the graph of y equals a sine of x, where a is some number, it ranges between negative a and a instead of between negative 1 and 1. So what we call that, what do we do with that? That absolute value of this number a is called the amplitude. Okay, we give it a name. That's how important it is. It's the amplitude. So the range of the function of y equals a sine of x for any positive a is negative a to positive a. All right. Let's see here. What else can I tell you? Okay, so another thing about amplitude, it's the amplitude for a sine of x and a cosine of x. It represents half of the distance between minimum and maximum values of the function, and we're given this as the absolute value of a. And we said that already, but that's okay. So remember that our transformations, graph of y is equal to negative f of x is a reflection across the x-axis. So if I took y equals 3 cosine x, see the gray right here? This is 3 cosine x. The amplitude is 3, so it goes all the way up to 3, and then it comes back down to negative 3 and back up to positive 3 and down to negative 3 and so on. If I was to find the graph of y equals negative 3 cosine x, so this this point right here gets reflected across the x-axis and now is -3. 0 stays at 0. At pi, at x equals pi, y is for the gray, the original, it will be -3. So the reflection of that will be +3, you see, and so on. So it's basically reflected across the x-axis. Okay, so since y equals a sine of x completes one cycle from 0 to 2 pi, it follows that y equals a sine of bx completes one cycle from x equals 0 to 2 pi over b. Okay, so where b is a positive real number. So this number in front of the x that's still part of the input of sine affects the period. What that means is, what's the period? That means how far, how long it takes for the curve to begin and then go back to its starting point on the y, right? So let's say here, so that we define the period of y equals a sine of bx and cosine of bx. A cosine of bx is 2 pi over b because it gets divided by this coefficient of x that you see right here. Now when b is between 0 and 1, that means that the period of this function a sine of bx is going to be greater than 2 pi, and then it represents a stretch, a horizontal stretch. And also if b is greater than 1, it's going to be a horizontal shrink, right? Because it's going to be, the period will be 2 pi over b, and it's greater than 1, so it's going to be some kind of fraction, okay? So when b is negative, right, we use the identities to rewrite the function. So remember, sine of negative x is equal to negative sine of x, and then we use cosine of negative x is equal to cosine of x. Okay, so let's sketch the graph of y is equal to sine of x over 2. Okay, there's no coefficient that we see in front of sine, so we know that it's 1, right? The coefficient of, when you don't see it, we know it's 1. So the amplitude is 1, okay? Also, b is 1/2, right? Because b is the coefficient of x, and x divided by 2 is the same as 1/2 x. So b is 1/2. So the period is 2 pi over b, which is 2 pi over 1/2, which ends up being 4 pi, because 2 divided by 1/2 is 4. All right, so then let's see. Now divide the period from 0 to 4 pi into 4 equal parts with the values pi, 2 pi, and 3 pi to obtain these points. So let's say we're going from 0, from x goes to 0 to 4 pi, right? So here's the period, see it in the red. And we divide that into 4 parts. So halfway will be another 0. So a good way to draw sine, honestly, you start at 0, you know, whatever. You know that it's going to start on the x-axis, it's going to end on the x-axis, and then halfway in between, it's going to have another intercept. Okay, so that's one way to think about it. So it basically has a point on 2 pi comma 0. So then halfway between that will be the maximum. So halfway between 0 and 2 pi is pi. So at pi, the maximum is 1, so there it goes there. And then the minimum will be -1 at 3 pi over 2, okay? I mean, not 3 pi over 2, 3 pi, sorry. Because halfway between 2 pi and 4 pi is 3 pi, okay? So let's talk a little bit about translations. Okay, so what if you have this c in here inside the argument of sine, okay? This creates a horizontal translation of the curves, okay? So the cycle goes from 0 to 2 pi for the input, correct? So if you think about this, okay, bx minus c goes from 0, and then bx minus c will go to pi at the end. So for one period, it goes from 0 to 2 pi. So solving, we can figure out, using this information, we can figure out lots of things. Okay, so let's say here, we solve for x. We see here that the interval for one cycle, so on the left side would be c over b. And on the right side, you would have c over b plus 2 pi over b, okay? So that means that it goes, that there's a shift of c over b, Okay, so because it's 0 plus c over b, there was a shift of c over b, and that's called the phase shift. Okay. So finally, we have here that the graph of y equals a sine of bx minus c and y equals a cosine of bx minus c have the following characteristics, where a is the amplitude, the period is 2 pi over b, and it has a phase shift of c over b. Or you can think of, what's the left and right endpoints? Just let the argument, whatever's inside the parentheses of sine, be equal to 0 on one, and then the other side equal to 2 pi, right? Let them equal to 0 to 2 pi to find the endpoints. And then to find the other points, just divide by 4, yeah? Or divide it in half and then half of that, however you want to do it. Okay, so suppose you want to sketch the graph negative 3 cosine of the quantity 2 pi x plus 4 pi. That's a mouthful. But we've learned enough already to talk about it. Okay, so the amplitude is 3, right? It's the absolute value of the coefficient of the function. So it's 3, and the period is 2 pi over b. What's b? It's whatever the coefficient of x is. So that's 2 pi. 2 pi over 2 pi is equal to 1. Now let's find the endpoints of this interval, yeah, of this period. So we have 2 pi x plus 4 pi. Let's set that equal to 0. If we get that equal to 0 and solve, right, subtracting 4 pi from both sides, dividing by 2 pi, we would get that x is equal to negative 2. So that's the left endpoint. And then to find the right endpoint, we're going to say, okay, fine, 2x pi plus 4 pi will equal to 2 pi. And let's solve that. And if you solve that, you get x is equal to negative 1. So the interval negative 2 comma negative 1 corresponds to one cycle of the graph. And if we split this into two parts, right, it's going to be, the space between these two is 1, so 1/4, right? So negative 2 plus 1/4 will give me negative 7 over 4. If I add 1/4 to this, I'll get 6/4 or negative 3 halves. If I add 1/4 to this point, negative 3 halves, I'll get negative 5 over 4. And then if I add 1/4 to this, I'll get back to negative 1, which is what I want. And then we know because it's minimum, intercept, maximum, intercept, and then minimum, we're going to have 1 at negative 3, and then 0, back to 3, 0, and then negative 3. And it looks like this. Okay, so this is a cosine. Because it's negative, remember that it usually starts up here, but because it's negative, it starts down here. Okay. Alrighty, so finally we have the vertical translation. So this constant, if you add a constant to it, which is just a number with no variables attached to it, it shifts up for d that's positive and down for d that's negative. So it's just a very typical translation, okay? So in other words, it oscillates about this horizontal line y equals d instead of the x-axis. So everything's the same except that now, instead of using the x-axis, you'll use the line y equals d. Okie dokie. So your super fun homework, 1 to 23 odd, 27 and 29. So good luck. Have fun practicing, and I will see you guys on the next video.